Kepler 186f is an Earth-sized planet that is about 500 million light-years away from Earth. It currently lies in the habitable zone of its solar system, and it is about 10% bigger than Earth. Some of you might be asking yourselves, how do you know all this about this planet that is so far away? How were we able to find this planet? Sit back and relax as we transit your mind from being blown to understanding what we're talking about. The transit method consists of both a direct and indirect methods of observing planets that are not in our galaxy. These planets, such as Kepler 186f, are called exoplanets. In order for us to be able to use this method at all, though, direct and indirect transit observations can only be made if the observer, Earth or satellite, is observing at the same orbital plane as the planet and star we want to observe. This means that the star and planet must be in direct visual alignment as Earth. The definition of a transit is to pass in front of a star, not planet-specific. Whenever an object passes in front of a star, that is considered a transit. So what is the indirect observation? The indirect observation of the transit method has to do with what we record when a transit happens. When the transit occurs, there is a dip in brightness in the light of star we are observing. The dip is just the object blocking the light from the star, so we can no longer see that light. That dip in brightness tells us something about that object. It can tell us how fast the object is moving, based on how long it takes us to get that full beam of light again, and its radius, which will give us the size of the object, and the area of the object. Even though we might have the size of the object, we still need more information, in order to even say that the object is orbiting the star we are observing, let alone it's a planet. So we still need more information to determine either of these criteria. The other way and more precise way would be to keep observing the star and wait for another transit to take place. So after you see the first transit, the best thing for you to do would be to see the amount of time it takes for another transit to occur. So if you see a second transit, you record the time it took from the last transit, and you keep observing and wait for another transit. If there's a third transit, and it matches the amount of time between the first two transits, then you can determine the object is in orbit with the star and potentially a planet. In order to determine an object is a planet orbiting a star, you must have at least 3 transits with the same time in between each of them. The amount of time it takes between each transit is actually the orbital period of the planet. The orbital period is the amount of time the planet takes to orbit its star one time. For example, Earth's orbital period is 365 days. Finding the orbital period is very important, because once you find the orbital period, you are able to find the distance between the planet and its star. According to Kepler's third law, p(2 equals a(3), in which case p equals the orbital period and a equals the radius of the orbit. So in this case, since we found the orbital period, you'd square it, then you'd take the cubed root of it to find the radius of the orbit, which would essentially give you the distance between the star and its planet. Okay, great, but what's the reason behind knowing the distance between the planet and the star? Reason the last part is important is because it will help us determine whether the planet is inside the habitable zone. What is the habitable zone? This is the location where a planet can potentially be capable to sustain life, most importantly, maybe sustain human life. It is the area where the planet has the capability to sustain liquid water. Remember Kepler 186f. This is the first Earth-sized planet ever discovered to be in habitable zone. That doesn't mean it's capable to sustain human life, but if it lies within the habitable zone, that's definitely a plus. Also, the size requirement for surface habitability is a size that allows plate tectonics to exist and retain internal heat. Reason you want the planet to retain heat is so you potentially have melted water, or bodies of water, and for the planet to be able to somewhat heat up and not be frozen tundra. The issue with Kepler 186f is that its star is about half the mass of our Sun, and it gets 1/3 the total energy. That can potentially cause some issues with its ability to foster life, but maybe one day, with the use of this method, we'll be able to find another Earth.